Okay, so for this video, we'll be discussing the paper 5 also, which is the probability and statistics 1 for the May-June 2023 series and paper 5 3. So we'll start with question number 1. We are given 2 coins and then they are fair coins, right? Okay, are thrown at the same time repeatedly until a pair of heads is obtained, until something happened. So this is a keyword. And when you are seeing this keyword, basically it tells us that it is a geometric distribution. Alright, so we're having a geometric distribution until a pair of heads is obtained. The number of throws taken is denoted by the random variable x. Alright, so basically for this one, we need to know that it is a geometric distribution. And after that, we need to know what is the parameter for this geometric distribution. So the parameter is, we need to know what is the probability of getting a pair of heads. Alright, so to get the probability of obtaining a pair of heads, basically we're having 2 coins, right? And they are fair. So the first coin getting a head is 1/2. The second coin also is 1/2. Therefore, the probability of getting a head is, a pair of heads will be 1/4. Which means that I'm having the geometric distribution with the parameter p is 1/4. And they're asking for the expected value of x. So the expected value of x basically is the mean. So what is the mean for geometric distribution? Okay, in our FM 19, the booklet, right? Basically, you can have a look here. For the geometric distribution, when you are having the parameter p, the mean is actually 1 divided by p. Okay, so if we come back to our question, to calculate the p, it will be 1 divided by the p. So p is 1/4. Therefore, the mean that we get should be a 4. This is part number 1, part A for question number 1. Okay, so let's have a look for question number B, 1B. Find the probability that exactly 5 throws are required to obtain a pair of heads. So we are still under the same geometric distribution here. They are interested to find out the number of throws, which is equals to 5. So x is the number of throws, and we write it out equals to 5. So to get the first pair of heads at the 5th throw, that means the first 4 throws, they are not getting a pair of heads. So if let's say the first throw, I didn't get a pair of heads, the probability will be 3/4. Same thing happened for the second throw. If the second throw I also didn't get a pair of heads, then the probability will be 3/4 as well. Then the third one also 3/4. The fourth one also 3/4. And then the fifth one, only we get a pair of heads. Therefore, you are having the probability 1/4. Okay, of course, you can write it out as 3/4 power 4 with 1/4 for the 5th time, right? And if you try to simplify this answer, it will be 81 divided by 1024 in the fraction form, or you can change it become 3 significant figure where it should be 0.0791. So this is what we have for part B, question number 1. Okay, so let's proceed to part number C. For part C, they want us to find the probability that fewer than 7 throws are required to obtain a pair of heads. Okay, so now we want to calculate the probability that we need only less than 7 throws to obtain a pair of heads. Okay, so just to recall back, to find out any probability in geometric distribution that is x smaller equals to something, there's basically a shortcut formula that we can apply, where if I want to find out x smaller equals to r, the shortcut formula is 1 minus q power r. Okay, so you can apply this one, which is much more shorter if you apply it in exact. Okay, so for now, I'm trying to put it inside our question here. I want to find the probability for x smaller than 7. But if you observe the formula provided, it should be include the equal sign. The r should be included. Therefore, I need to rephrase my equation again, my phrase again here. I want to change it become x smaller equals to 6. Smaller than 7, and it is a discrete random variable, right? Therefore, you can rewrite again become x smaller equals to 6. They're having the same meaning here. So you can see from here that our r is a 6. Therefore, to calculate the probability, you can directly take 1 minus q. What is the value of q? Q is 3 over 4 in this case, right? P is 1 over 4. Therefore, the q will be 3 over 4. So I'm having 3 over 4 power 6. And then you try to simplify the answer, it will be this one in the fraction form. Or you can change it become answer in 3 significant figure where it should be 0.822. Right, so this is how we answer question number 1. You need to identify that this question belongs to geometric distribution. Okay, so now we are at question number 2. We have Anya is a candidate in the election and then he received 40% of the votes. A random sample of 120 voters is chosen. So use an approximation to find the probability that of the 120 voters between 36 until 54 inclusive voted for Anya. Right, so for this question, basically the very obvious keyword will be this one, approximation. So in AS labels, right, in steps 1, we are having only one type of approximation where we are going to change the binomial become normal distribution. So which means that the original distribution for this question is binomial actually. All right, so let's say X is the number of voters, okay, and we are having 120 voters at first, and then the percentage of received the vote will be 40%. So I'm having the P, which is 0.4. Since they tell us clearly that we need to use an approximation to find the probability, therefore you have to change binomial become normal distribution. So to get the parameter in the normal distribution, right, the first value here should be a mean. So how can we calculate the mean from binomial distribution? So to calculate the mean, I should take n, this is the n, multiply with the p to get the mean for binomial. Alright, so for the first value here in normal distribution, also I need the mean. So mean is 120 multiplied with 0.4. So from here I'm having the mean, which is 48. The second parameter here in the normal distribution should be a variance. So to get the variance, the formula should be npq. So n times p times q. Q will be 0.6. And from here you'll get 28.8 for your variance. Alright, so just to recall back, this is actually from NP, which is the mean, and then the variance formula from binomial is NPQ. Okay, then now let's proceed to the probability part. They want us to find the probability where the number of voters should be 36 until 54, inclusive. So the keyword inclusive means that you have to put an equal sign here, and I'm having 36 and also 54. Alright, so again, binomial distribution is a discrete random variable. Okay, and then for normal distribution, it is actually continuous random variable. Therefore, when you want to change from discrete to continuous random variable, you actually need the continuity correction. Okay, so to get a continuity correction, you should include the 36, the value 36. So the continuity correction should be a value earlier than 36, which is 35.5. Okay, and then after that for 54, your x include 54. So when you want to apply continuity correction, the value that you write should be after 54. So it should be 54.5. Okay, and since I know that this is a normal distribution, right? Therefore, to find the probability, I need to standardize them become z first. Okay, so how to standardize them? I need to take the value of x minus the mean. So minus the mean means that minus 48 divided by standard deviation, which is square root 28.8. The 28.8 itself is a variance. So I need to divide it by standard deviation. Therefore, I have to take square root of variance, which is standard deviation. Okay, so simply happen for this value 54.5, I have to minus the mean divided by standard deviation as well. So from here, I will get my value of z, which is negative 2.329 and also 1.211. Okay, then please take note for the value of z, we'll try to write it out into 3 decimal places because the accuracy for our normal table provided, right, can be up to 3 decimal places for the value of z. Okay, so now I want to find out this area, the probability of this area. Okay, so if I try to figure out or try to imagine it or try to display it by using a normal curve. Okay, so this is the 0. And then I want to find out the probability between 1.211 and also negative 2.329. So this is the area that I'm interested to find out. Okay, so to find out this probability, they are having many different ways that they can apply. Alright, so for me, I will use the basic one, where if I want to find out this probability, basically I know that I need to find out this red color area first. So for this red color area, if I write it out, it should be the probability of Z smaller than 1.211. And after that, I need to minus this small area of purple color. If I take the red color area minus the purple color area, then I will get the shaded area that I want. Therefore, if I write it out, it should be minus the probability of Z smaller than negative 2.329. Okay, so of course there are some other steps that if you want to apply, you can apply some other steps. Some students might take 1 minus the 2 area by the side also can. Alright, okay, then now I will start to find out the probability. Z smaller than 1.211. So I go to my MF19, the normal distribution function provided. My Z is 1.211, right? Okay, so according to the table, they are providing the area smaller than. So I'm looking for the area smaller than 1.211. So scroll down, look for 1.2. This is the 1.2, 1, and 1. Which means that we are looking for this value, the probability value, 8869. Then you have to plus a 2 at the back, at the last digit. So if you plus a 2 as the last digit, you should have 8871. Okay, so when you want to write out in the probability part, it will be 0.87, also 8871. So it will be 8871. Okay, then minus, for this area, right, it is a small area in our table, in our graph, and also you can see that the value of Z is a negative value. But if you try to have a look for the normal table, our all value of Z will be the positive value. Okay, so what we need to do is that we have to imagine the 2.329, right? You have to reflect it to the right hand side. Okay, become 2.329. So for greater than 2.329, right? To find the small area, you can take 1 minus the big area, which is smaller than 2.329, to get a small area on the right hand side. Therefore, you have to take 1 minus, okay? So I'm looking for 2.329. So 2.3, 2 is this one, then 9. Okay, which means that you can take this value, 9898, and you have to add a 2 at the last digit, and you are having 9900. Okay, so when I want to put it inside my step here, it will be 1 minus 0.9900. Okay, so try to simplify this step here. You have at 0.8771. Of course, if I want it to be safe, I will change it, become 3 significant figure for my final answer. And I'm having 0.877 correct to 3 significant figure. So this is how we find out the probability for this area. Okay, so for question number 3, we have the random variable x takes the value 1, 2, 3, 4, and then it is given that the probability for x, right, it follows this formula. Okay, so that means now when x equals to 1, to calculate the probability, you have to substitute x as a 1, x as a 1. So the value that you get here will be the probability of x equals to 1. Okay, where k and a are constants. Given that x equals to 4, probability equals to 3 times of the probability of x equals to 2, they want us to find the value of a and also the value of k. Alright, so first of all, we have to try to find the value of a and k first. Okay, so from where we should start? You can start from the information given by the question first if you want. So they are saying that x equals to 4 probability equals to 3 times of x equals to 2 probability. Okay, so maybe we can try to figure out how to find out the probability for x equals to 4. So like what I mentioned just now, the value of the probability, right, is according to this formula. So that means when x equals to 4, you have to substitute the 4 here. You also need to substitute the 4 over here. So that means if you try to simplify, right, you are having 4k multiplied with 4 plus a. So for this probability, it will be 4k and then multiply with 4 plus a. Equals to 3 times. So you just write as 3. Then what is the probability for x equals to 2? So now what you need to do is you have to substitute the 2 inside the x here to get the probability. So if this is a 2, this is also a 2. Basically, you're having 2k and then 2 plus a. Okay, all right, then after that, how can we simplify it? Okay, so to simplify it, maybe you can expand the whole equation here. I'm having 4k multiplied with 4 plus a, and then equals to 6k multiplied with 2 plus a. Okay, then what I am going to do now is maybe I move all the terms to the other side, to one side lah. Of course, if you want, you can expand everything to get the answer. Okay, expand everything and simplify them, or you can just try to factorize it like me. So what I'm going to do now is I will want to factorize out the 2k from both terms here. If I factorize the 2k, right, this one I still have a 2. So 2 times 4, you get 8, then plus 2a. This one, if I factorize out the 2k, I'm still have negative 3, right? So negative 3 times 2, I'm having negative 6. Then negative 3 times a, I'm having negative 3a. And then it is equals to 0. Then I can further simplify the bracket here. So 8 minus 6 is a 2. 2a minus 3a is a negative a. And then it is equals to 0. Okay, so from here, right, we can actually see quite clearly that to solve this equation, I'm having 2k equals to 0 and also 2 minus a equals to 0. Okay, so 2k equals to 0, 2 minus a equals to 0, and I'm having my value of a, which is equals to 2. Okay, and then for this part, now, if you continue to solve for the k, right, you'll get a 0. Basically, we should ignore this answer. Why should we ignore this answer? It is because of if I put k equals to 0, right, then you will see that the probability of our random variable x, everything will become 0, which is not logic. It must be some value, right, for the probability. Okay, therefore, k cannot be equals to 0 because if it is equals to 0, then we won't have any probability for our random variable x. So we ignore the value for k equals to 0 and we get the value a equals to 2. Okay, then how can I continue further to get the value for k? So to get the value of k, you need to use another concept where we know that if I try to add all the probability together, right, it will be always equals to 1. Okay, so which means that now we are going to use this information here for the random variable, discrete random variable, okay, to help us and find out the k. Okay, so let's start. So first value of k is a 1, right? So that means you have to substitute the 1 here. Therefore, you're having k and then 1 plus a. 1 plus a, you know that a is a 2, right? So 1 plus 2, you get a 3. So you're having 3k for the first probability. Then plus, next we move on to x equals to 2. So if let's say this is x equals to 2, substitute the x equals to 2 inside the x here. I'm having 2k. So 2k, 2 plus 2 is a 4. So 4 times 2, you get a 6, right? So you should have a 6k. Or if you want, you can write out as this one, 2k multiplied with 4. 2 plus 2 is a 4, right? That's what I think I mentioned wrongly, right? Okay, so again, if I substitute a 2 here, so it should be 2 plus 2, which is equals to 4, and then the value of kx means 2k when x equals to 2 lah. Then now we move on again to x equals to 3. So if I move on x equals to 3 here, substitute this as a 3, substitute this as a 3, this one is a 2. So 3 plus 2 is a 5. So I'm having 3k multiplied with 5. And lastly, we're having x equals to 4. So substitute the value of 4 here. Okay, and then I'm having 4, then 4, then 2. So 4 plus 2, I get a 6. Therefore, when I write it out, it should be 4k and then multiply with 6. and it is equals to 1 basically. So I try to add up all the k together. So 3 plus 8 plus 15, then plus 24. Okay, it is equals to 0. Therefore, I'm having 50k. Oh, sorry, it shouldn't be a 0. Right hand side should be a 1. So equals to 1. Therefore, the value of the 50k equals to 1. And then the k will be having the value of 1 over 50. And this is how we get a value for k. Alright, so of course, at first, we need to use the information provided in the question to find out the value of a first. So we successfully found the value of a. Then after that, only we use the information for discrete random variable, where the total for the probability should be equals to 1. Therefore, by using this information, I'm getting the k equals to 1 over 50. Alright, then now let's proceed to part B. Okay, so for part B, they want us to draw up the probability distribution table for x, giving the probability in the numerical fractions. Okay, so I try to rewrite again. What is the formula for our probability here? Okay, it is actually equals to kx multiplied with x plus a. And all the value of x that we have is 1, 2, 3, 4. Okay, alright, so to draw the probability distribution table for x, then you should form a table. So usually we are having 2 rows here for this kind of table, and then first row basically we will put in the value of x, and then the second row we will put in the value of the probability. So we are having 4 values of x, right? We are having 1, and then 2, then 3, and also 4. Okay, so now substitute x equals to 1 into the formula. So I'm having k times 1, and then 1 plus 2. So if you have a look here, you simplify the value. 1 plus 2 is a 3. 3 multiplied with k, which is 3 over 50. So the probability for x equals to 1 will be 3 over 50. Same thing happened for x equals to 2. So you substitute 2 inside our formula. So I'm having 1 over 50 times 2, and then 2 plus 2. Okay, if you simplify this phrase here, you are having 8. So it will be 8 over 50. Alright, then again, same thing happened for the 3. So you substitute 3, and I'm having 3 plus 2. Simplify this phrase or this term, I'm having 15 over 50. Then lastly, we substitute x equals to 4 into the formula also. Okay, and by right, you should have 24 over 50. Okay, so this is how we show the probability distribution table for x. You have to write out the probability by substituting the value inside the formula. And according to this question, they want us to put our probability as a numerical fractions. So you can say I put it in the fraction form. Alright. Okay, so this is how we solve part B. Then continue to the next one, which is part C. So for part C, they give us the important value mean. Mean is equal to 3.2. They want us to find out the variance. Okay, so to find the variance, before you can find the variance, right, we actually need the expected value of x squared. Okay, so how to find the expected value for x squared? Basically, the formula is you multiply x squared with the probability, and then you total them together, and minus the mean square. So to calculate the mean, it is xp squared. Okay, or if you want it to be more simplified or easier, then you can straight away write out the mean and then you square it. Since the mean is provided, so you can substitute 3.2 straight away later. Alright, okay, so we'll start, minus mean square, it is for variance, so for expected value of x squared should be this one only, summation of x squared multiplied with p. Okay, so the formula that I showed earlier, that minus the mean square one, it is actually the formula for variance. So we start with this one first, expected value for x squared first. Okay, so x squared means that you take the value of x. According to the table, the first value of x is a 1, and this is the p. So when you write it out, it should be 1 square multiplied with the p, which is 3 over 50. Then you add, you plus. The second value for the x is a 2, right? So 2 square multiplied with the probability for 2 is 8 over 50, and so on. So I'm having 3 square also, probability is 15 over 50. Then 4 square, then we are having 24 over 50. Okay, so by using the help of calculator, you should be able to get a fraction, 277 divided by 25. Okay, so please take note that I'm going to keep this as a fraction for my answer, because this is not my final answer yet. You have to continue to calculate the variance. So to get the most accurate answer, basically we encourage students to keep your answer in the original form. So for me, the fraction is actually the original form, I would say. Okay, so don't cut your answer become shorter, because your my final answer might be affected if you do so. Okay, then now I want to calculate the variance. So to calculate the variance, I have to apply the formula, the expected value of x squared, then minus the mean square. Okay, so the expected value of x squared I just found out, right, just now, 277 over 25. Then minus the mean. Mean is given, which is 3.2, and then we square it. And from here, we are having 21 over 25, or 0.84. Alright, so this is basically how we solve this question number 3C. Okay, so let's discuss question number 4. We are having the time taken in minutes to complete a cycle race by 19 cyclists for each of the two clubs. We are having the cheetahs and panthers, and then they are representing in this back-to-back stamp plot. Okay, so maybe you can have a look for the key here. Everything is measured in minutes. All right, so find the median and interquartile range for the time of the cheetah. So cheetah is this one. Okay, we are having 19 cyclists. So to calculate the median, we need to know where is our center value for the whole set of data. Okay, so if I'm having 19, right, I can nicely separate them, become first half, okay, of the data is consisting 9 value. Then I'm having 1 value in middle, and then the second half I have another 9 value here, so that 9 plus 9 is 18, and then include this one is 19. So I'm having 19 value here. So this particular value, right, we are having 9 value in front, so this is actually my 10th value of this set of data. Alright, therefore, to get the median, I need to find out the 10th value from the beginning. So I just count one by one. This is the first value, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a 10 value here. And if we read the value from the back-to-back stamp plot, right, it should be 99 minutes. So I will write it out as 99 minutes here. Okay, and after that, to calculate the interquartile range, I need Q1. So how to find the Q1? So Q1 basically is the median for the first half of the data. Okay, so I'm looking into this one. This is my first half of data, first half. And what is the median from the 9 value here? So again, I will want to split it become two sections. The first one will be 4 value. I have 1 value in the middle, and then the second half will have another 4 values here. So that 4 plus 1, which is equals to 9. So total there are 9 values, right? And then for this particular value in the center, it is actually my 5th value here. Okay, again, to calculate or get the Q1, I have to count my data from the beginning until the 5th value. So 1, 2, 3, 4, 5. So 5, this is the 5th value here, and it will be our Q1. Okay, so I write out the Q1 first. It will be 83 minutes. Next, I need to have Q3. So same thing happened for Q3. It will be actually the median for second half of data. So this is my second half of data. I want to separate this 9 value into two sections. So the first section is having 4, 1 value in the middle, and then the second section is 4. That means this one is the 5th value after the median. Okay, so I need to count the 5th value after the median. So you can see that 99 is my median, right? So I need to count 5th value. So 1, 2, 3, 4, and also 5. So this will be the 5th value after median, which is actually my Q3. So the Q3 that I get here is 106 minutes. Okay, and after that, I need to continue to get my interquartile range. So to get the interquartile range, you need to take Q3 minus Q1, and from here, you'll get 23 minutes as your interquartile range. Right, so for the unit, I will strongly suggest you to write out the unit. Okay, so this one they are talking about the time taken to complete a circle, a cycle race, right? Yeah, therefore it's in terms of minute. So usually for me, I will just write out the unit in my calculation. Okay, so this is what we have for part A. And then for part number B, they said median and interquartile range for the Panthers are 103 and also 14 minutes respectively. So they want us to make two comparisons between the time taken by the cheetah and also the time taken by the Panthers. Okay, so before we can make any comparison, let's have a look for the value given first. So for this question, they give us the value of median and also the interquartile range. So for information, right, median, basically we are talking about the central tendency, all right, that denotes the whole set of data. So this is actually about central tendency. That means later when you want to make any comparison, you have to compare the median first, which is talking about the central tendency. And then the interquartile range, basically they are talking about spreadness of the data. So when they want you to make two comparison, right? So one of the point must be coming from the central tendency, which is median, and also another point should be coming from the spreadness. Talking about spreadness, which is actually can be observed from the interquartile range, right? Okay, so if let's say I'm trying to compare the median, so the median for cheetah will be this one, 99, and the median for panthers is 103. So basically 103 is faster, right? Okay, so you can see that, oh sorry, 103 is longer time. I'm so sorry for that. 103 is a longer time, and then 99 is a shorter time. So that means if we want to comment about which group is faster, basically cheetah should be faster. So you can say like this, the time taken for cheetah, right? The time for the cheetahs faster because the time taken is shorter, right? So faster than the panthers. So this first sentence here, we are talking about the median, which is a central tendency. And then after that, we are talking about the spreadness, interquartile range. So you can see that for cheetah group, the interquartile range value is larger. And then for panthers one, the interquartile range is smaller. Since interquartile range are talking about the spreadness, they measure about the spreadness. Therefore, you can write out like this. The group in cheetah is more spread, right? So you can write it like this, the time for cheetah okay, more spread because the value are larger. Okay, so are more spread than the panthers. Okay, so you can see that the 2 points here are talking about two different things, where the first one is talking about central tendency and the second one is talking about spreadness. Okay, all right, then after that, let us proceed to part C. So for part C, there's another cyclist, which is CAIE. Okay, from the cheetah also took part in the race. The mean time taken by the 20 cyclists from cheetah was 99 minutes. They want us to find the time taken by CAIE to complete the race. Okay, so originally we are having 19 cyclists, right, in the back-to-back snap block, and now they add in one more cyclist, which is CAIE. And then when CAIE has been added into the group, right, the mean become 99. Now they want us to calculate what is the time taken by the CAIE to complete the race. Okay, so first of all, when we want to calculate the mean, basically we need to add all the data together, right? Okay, so for cheetah's group, we have to try to add up all the value here, 78 plus 79 plus 80 plus 82 plus 83 and so on. So please add up all these 19 values here. By right, you should have 1862. This is the total time taken for the 19 cyclists. But since we are having 20 cyclists now, right? So I want to know after add in CAIE. So let's say CAIE's time is the X. Okay, divided by the total cyclists, where now it becomes 20 because 19 plus 1 become 20, right? The new mean that we get is actually 99. So this is how we form the equation. And after that, by moving all the number to the other side, we will get the value for X, which is 118 minutes for CAIE to complete the race. Right, so this is how we answer question number 4. Okay, so question number 5. Jasmine throw 2 ordinary fair 6-sided dice, okay, at the same time, and note the number of the uppermost faces, and then the event A and B are defined as follows. So we are having event A where the sum of the two numbers is less than 6, and then for B is difference between the two number is at most 2. They want us to determine whether the event A and B are independent or not. Okay, so for me to visualize this question clearly, okay, what is the outcome that I have? What I will do is I will try to draw a possibility space diagram to help me visualize clearly what do I have here. Okay, so to draw a possibility space diagram, because we are having two dice, right? Okay, so the method that is suitable will be the possibility space diagram. It might need some time to set it up, but to me, I think it is clear enough to show all the possible outcome that we have for this question. Okay, so we are having dice number 1, where the 6-sided would be 1, 2, 3, 4, 5, 6, and then the dice number 2 will be 1, 2, 3, 4, 5, 6. Okay, and then now because there are many ways for us to display this possibility space diagram. Okay, so for me, because now I only want to focus on the event A and B, which is defined in the question, therefore I will mark the result by using the A and B. Okay, the letter A and also the letter B. Okay, so I will show you like this. Wait. Okay. So let's have a look for the event A. For event A, right, they're talking about the sum of the two numbers is less than 6. So I will try to check cell by cell. Okay, let's say for the first cell here, is the sum less than 6 or not? 1 plus 1 equals to 2, right? So it is less than 6. Therefore, it is belongs to event A. So for me, I will just write it out as A here. Okay, so that means this particular cell fulfill the event A. So 2 plus 1 is a 3, which is also less than 6. So I put it as A also. 3 plus 1 is a 4. 4 plus 1 is a 5. 5 plus 1 is a 6. 6 doesn't belong to less than 6. Less than 6 means the shouldn't include the 6. So you should ignore this one. So I didn't write out the A here. 6 plus 1 is a 7. Therefore, I didn't write out the A here. So basically, I will want to fill up and check through the cell which fulfill the event A first. Okay, so 2 plus 1 is a 3, 2 plus 2 is a 4, 2 plus 3 is a 5. 3 plus 1 is a 4, 3 plus 2 is a 5. 4 plus 1 is 5. Then 5 plus 1 already a 6. There's no more A at this part of the graph, or this part of the positive space diagram. Then now I proceed to event B. Event B talking about the difference between the two numbers is at most 2. So it can be 0, it can be 1, it can be 2, but it cannot be 3. So they're talking about difference. So as an example, for the first cell here, 1 minus 1, I get a 0. Therefore, it belongs to the event B. So I will put a B here. So for a particular cell that appear both A and B, right, it actually means that A intersect B. Okay? Right, so for the next one, 2 minus 1, you get a 1, so it belongs to B also. 3 minus 1, you get a 2, so also belongs to B. 4 minus 1, you get a 3, so it does not belong to B anymore, because you can see that it's at most 2. So 4 minus 1 already more than 2, right? So you shouldn't write a B here. So same thing happen for all the rest of the cell. Alright? Okay, then for this particular cell, 2 minus 1, I get a 1. 2 minus 2, I get a 0. 3 minus 2, I get a 1. 4 minus 2, I get a 2. So I should put B under this part. Same thing happen for this. 3 minus 1, I get a 2. 3 minus 2, I get a 1. 3 minus 3, I get a 0. 4 minus 3, I get a 1. 5 minus 3, I get a 2. So it should be included for this one. Okay. Then 4 minus 1 for this particular cell. 4 minus 1, I get a 3. So I will not put the B over this cell. And then the rest, yes, 4 minus 2, 4 minus 3, 4 minus 4, 5 minus 4. 6 minus 4. 5 minus 4, 5 minus 1, I get a 4, no. So 5 minus 2, I get a 3, also no. Then it should be start from here. 5 minus 3, 5 minus 4, 5 minus 5, 6 minus 5. Okay, then the last one will be this 3. Okay, so although it might need some time for us to setting up this question like this, but basically to me it will be very helpful later when you want to get any probability. Okay, that you no need to worry you miss out any possible outcome, or maybe you didn't consider any possible cases that should be included. Alright, so to me, this is a very, how to say, straightforward and a very straightforward diagram, okay, to help us visualize the probability. Okay, so now since they want us to test whether A and B are independent or not, okay, so just to recall back, to prove whether A and B are independent or not, if the probability of A multiplied with B, right, equals to A intersect B, then they will be independent. Okay, so if you're having this equation, left hand side equals to right hand side, then A and B are independent. So to prove whether A and B, to determine whether A and B are independent or not, I need to find out the probability on the left hand side, then find out the probability on the right hand side, then I compare them. Okay, so let's start with the probability of A first. So to calculate the probability of A, basically what you need to do is just count how many cells with A in our possibility space diagram, then over total. So total cell is 36. Okay, so if I count the A, right, I'm having 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 cell with the A, therefore I'm having 10 over 36. Okay, which is 5 over 18. This is the A. What's the probability for B? So to calculate the probability for B, again, you count how many cells with the B in our possibility space diagram. If you count it carefully, you should have 24 cells with the B. And then 24 divided by total cell, 36. And you're having 2 over 3. Okay, so now I want to find the value for A multiplied with the B. So if you take A multiplied with B, you're having 5 over 18 multiplied with 2 over 3. And then this one should be 5 over 27. Okay, I settled for the left hand side. Okay, for the formula. Then now I want to focus on the right hand side. So for the right hand side, I am looking for the value of A intersect B. So to find the value for A intersect B, you need to check how many cells are there with both A and B in the cell. So this is 1, 2, 3, 4, 5, 6, 7, 8. So we are having 8 cells where A and B happen at the same time, then divided by 36. Therefore, you are having 2 over 9. So this is the answer for the right hand side. Okay, then to check whether are they independent or not, so you compare the probability of A multiplied with B is not the same as the probability of A intersect B, right? I think the value are very obvious here, you can compare. Therefore, your conclusion is A and B are not independent. Right, so this is our conclusion for the event A and also the event B. Okay, so all the probability here, basically I take it up from the possibility space diagram. Okay, alright, so let's proceed to part 2. For part 2, they want us to find out this probability where it should be a conditional probability. So for this conditional probability, right, if you want to write it out in the formula form, it should be B intersect with A prime, then divided by the probability of A prime. A prime means the event A doesn't happen. Okay, so maybe we are interested on the cell where B intersect with A prime first. So B intersect with A prime, basically it means that if I have the cell with the B but no A, so that means this one actually means that B and A prime. We have B but no A, right? So that means no A means A prime. So this is actually the intersection for B with A prime. So this one also B with A prime, B with A prime, and so on. So to calculate the probability, right, you just need to count how many this type of cell that we are having, A prime with B1. Okay, so you can try to count it. Okay, so it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? Therefore, we are having 16. So 16 over 36 divided by the probability of A prime. So just now we get the A probability, which is 5 over 18. So the probability of A prime, you can take 1 minus 5 over 18. Okay, so From here, you try to simplify using calculator, and then your final answer should be 8/13. So basically, this is how we answer this question number 5. Okay, so question number 6. They are talking about the mass of grapes sold per day by a large shop can be modeled by normal distribution. So please highlight the keyword normal distribution. The mean given is 28. So 10% of the day less than 16 kilogram of grapes are sold. They want us to find the standard deviation. Okay, so basically for this question, we already know that it is a normal distribution, right? So I'm having 28, and the standard deviation, I don't know what is it, and I want to find out. Okay, so to find the standard deviation, we need the information to start with, to start off. So the information given is this one. 10% of days, we are having less than 16 kilogram of grapes are sold. So that means the mass of grapes sold is less than 16, and the probability given is 0.10. So this is from this particular sentence. Okay, 10% means the probability or percentage, right? So you can make it become 0.1. Okay, since I know that this question is normal distributed, therefore I can change it become Z before you can calculate the probability. So how to change it become Z? We have to standardize it, where you have to minus 28 minus the mean divided by standard deviation. And we know that it is equals to 0.10. To find out the value of Z from the normal distribution table, I will want to visualize it by using a normal curve first. For this particular equation, Z smaller than this value equals to 0.1. Basically, you should know that the value of Z should be at this side. It is because of when the Z is at this side, right, is a negative value, then the area for Z smaller than this value only will get a small area here, which is 0.1. Okay, then of course the complement area will be 0.9, right, because the total should be equals to 1. Alright, so now our aim is to find out the value of Z, the critical value from the normal distribution table here. Okay, of course you cannot observe by using the 0.1, which is a small area, because in our table, the probability that they provided are all more large area, which is more than 0.5. So to get the answer for the Z, you need to refer to the large area here, which is 0.9. Okay, so what you can do now is you try to find out 0.9 from this side, go out and find out the value of Z, because we are now interested at the value of Z. Okay, but for your information, right, in our table, we are having a critical value for normal distribution. So usually we will try to find out and see whether our critical value belongs to this part or not. Area is 0.9, therefore I maybe can try to find out this table. 0.9 is the probability, so you refer to the probability part here, and you can see this is my 0.9. What is the value of Z for 0.9? It will be 1.282. Okay, come back to the question here. I know that my Z now is 1.282, but from the diagram that we draw just now, right, you can see very clearly that the Z should be a negative value. Therefore, when you want to compare it with the value of Z that we get from the table, we should write this equals to negative 1.282. Okay, because from the diagram, I can see very clearly Z should be a negative value. So when I find out the 1.282 already, I just put a negative in front of the Z. Okay, so that it fulfills what we have in the diagram. Okay, then after that, we'll try to simplify everything here and get the answer. Therefore, the sigma should be 9.36, correct to 3 significant figure. So this is how we answer part A. Then now let's proceed to part B. For part B, right, they are talking about the mass of grapes sold on any day is independent of the mass sold on another day. We are having 12 days in total now, where this is actually the fixed trial, right? So 12 days are chosen at random. They want us to find the probability that less than 16 kilogram grapes are sold on more than 2 of these 12 days. So when you're having 12 days, which is a fixed trial, and then more than 2 days, something happened. This kind of structure belongs to binomial distribution. We are talking about number of days now, right? So I put it as y lah. So y is binomial distributed. The total day we have is 12 days. And then the p, I want to find out the probability of less than 16 kilogram of grapes are sold. It is provided just now, less than 16 kilogram of grapes are sold. The probability is 0.1 or 10%. Therefore, I can put it as here as 0.1. They want us to find the probability that y is more than 2. So when they're talking about y more than 2, right? By right, you should accept the value, the probability for y equals to 3, y equals to 4, y equals to 5, until y equals to 12, which is too long. So for us, we will take 1 minus 0, 1, and 2. So 0, y equals to 0, the formula will be 12C0, 0.1 power 0, 0.9 power 12, right? This is for the value y equals to 1. When y equals to 2, it will be 12C1, 0.1 power 1, 0.9 power 11. Then y equals to 2 will be 12C2, 0.1 power 2, 0.9 power 10. Okay, then if you try to simplify all this by using the calculator, your answer should be 0.111, correct to 3 significant figure. Okay, so this is what you have for 11 part B. Then let's proceed to 11 part C. Okay, now I'm having another random sample of 65 days. I want to know how many of the grapes are within 1.3 standard deviation of the mean. When they are talking about the mass of grapes within 1.3 standard deviation of the mean, right? Okay, that means the difference between the x and also the mean should be less than 1.3 standard deviation. When we want to write out the symbol, it should be x minus mu. X means the mass, okay, mu means the mean. Okay, but when they're talking about the mass between the difference between the mass and also the mean, it can be also mu minus x. Okay, therefore, when we want to write out the symbol for this one, right, usually we'll put a modular sign for x minus the mu. Okay, because you can from the sentence, from the meaning of this sentence, right, basically it can be having two meaning, where the value x minus mu is less than 1.3 standard deviation. Another one is mu minus x is also less than 1.3 standard deviation. So usually when we want to do the calculation for this kind of question, you put a modulus for x minus mu, which means that it can be two directions, it can be x minus mu or mu minus x. Then within means smaller. 1.3 standard deviation means 1.3 sigma. So usually for me, I will write out like this. Okay, when we are having the modular sign, if I want to expand it, I'm having negative 1.3 sigma, and then x minus the mu, then 1.3 sigma. Okay, so I feel that the sigma here is very troublesome, right? For me to calculate the probability. So what I'm going to do is, I want to divide everything by sigma. So 1.3 negative 1.3 sigma divided by sigma. Same thing happens for all the parts inside the probability. Okay, so I think it's very clear that you can see now, I'm having the 1.3 here as a pure value. X minus mu divided by standard deviation, right? This whole thing basically is exact. And then on the right hand side, I'm having 1.3 also. Okay, and now we need to find out this probability first before you can get the expected number from 365 days. Okay, so I'm interested to find out this negative 1.3 and also 1.3. I want to find out this probability. Okay, so again, to find out this particular area here, there are many different ways that you can do it. You can take 1 minus the both area at the end of the diagram. It can, no problem. Or for me, I will usually use like this. I want to find out this red color area first, where if I write out this red color area, it should be z smaller than 1.3. After that, if I minus the small purple color area here, then I will get the shaded area that I want, right? So it will be minus z smaller than negative 1.3. Okay, to find the value for z smaller 1.3, you can get it from the normal table. So 1.3, what's the value for 1.3 here? Okay, so this is 1.3, right? And then the value that we get is 9032. So probability z smaller than 1.3 will be 0.9032. Then minus, if I want to find this small area z smaller than negative 1.3, so if let's say I'm having z smaller than negative 1.3, this area is actually the same like this area, which is z greater than 1.3. So to find z greater than 1.3, you have to take 1 minus the large area on the right hand side, right? So you have to take 1 minus 0.9032. Okay, so all these are some basic. So if let's say you don't understand what am I writing here, basically you need to go back to chapter 5 in your stats 1 notes to recall again, all right, the detailed steps on finding out all the probability. Okay, all right, so if you simplify the expression here, you should get 0.8064. Okay, this is not my final answer yet because they are interested to find out the expected days from 365 days. How many of them are within this situation, all right, this condition? Okay, after I calculate the probability, I have to take 365 multiply with the probability that I have so that I can count how many expected, what's the expected days that we have. So the number of days, right, it should be a decimal number. Okay, then by right, you can change it become integer because they're talking about the number of days. Okay, so when you're talking about this number of days, right, when you press calculator, it should be a decimal number. It should be 294 point something lah. All right, so no matter it is 294.5 above or 0.4 below, basically they will accept the integer before and after the value that you get. Okay, so for number of days, it should be an integer. So you can write either 294 or 295 days as your answer. Okay, so we actually observe that for marking scheme, they will accept the two integer before and after the value that you get actually. Okay, so for this one, if you try to press calculator, you should get 294 point something. Okay, so in marking scheme, they accept 294 or 295. Right, so this is how we answer question number 6. Alright, so now we come to the very last question for this paper. Okay, they want us to find the number of different arrangement. Highlight the keyword arrangement, where this is telling you that the question involved here is a permutation question. So in your step later, they very likely will have factorial, then NPR, right? So we are having 10 letters in this word, and then the condition here, the restriction here is, the restriction is 2C are not together. Okay, so first of all, I might want to figure out first how many letters do I have and how many identical letters that I have. So I'm having 2C from the word, and then 4A, 1S, 1B, 1L, and also 1N. So this is what we have here from the 10 letters. Okay, since they said the C are not together, that means C must be separated. Therefore, I will arrange them lastly. So I will arrange all the C at last. So first, I will focus on the remaining 8 letters first. I want to arrange the 8 letters here. So to arrange the 8 letters here, the number arrangement will be 8 factorial. 8 items, right? So 8 factorial. But because of I'm having 4 identical letter A in my arrangement here, therefore I have to divide it by 4 factorial. Okay, so this is what I do first. After that, I want to slot in the 2C between all the letters. Okay, so let's say I'm having 8 letters, right? 1, 2, 3, 4, 5, 6, 7, 8. To slot in the 2C inside the letters, I have to slot them inside the space between the 8 letters so that to ensure that the 2C are separated. Right, so how many empty space available for the 2C? So if you count the arrow here, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 space available for the 2C. So I want to arrange 9P2. That means arrange the 2C into the 9 available space. But because the 2C are identical letter as well, right? Therefore, you have to divide it by 2 factorial. So this part is basically for the C. This part basically is for all the 8 letters that we arrange them first. Okay, then simplify this particular phrase here. You should get 60480. So this is what you have for part A. So let's proceed to part B. Okay, for part B, again, highlight the keyword arrangement. Now they are talking about, we are having the A at the beginning, A at the end, and also exactly 3 letters between the 2C. Okay, so for me, right, what can I observe here is, I'm having A, or maybe I should draw a table, which is easier, right? Okay, wait. Okay, so maybe I'm having something like this. 10 letters, 1, 2, 3, 4, 5, 6. Maybe I put it like this. A, then 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, right? Sorry, 1 letter extra. So total, there should be 10 letters in total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from here, you can see very clearly that first letter start with A and letter also A. And then they have an extra restriction here where the C, the 2C should have 3 letters between. So maybe the first case is I'm having the C here, 3 letter empty, then the next C will be somewhere here. Okay, but of course you can observe that this is not the only case, right? Okay, we also can have where the C is this one, and then 1, 2, 3, C is here. Okay, then next possible layout will be something like this. And one last one will be somewhere here. Okay, then you can see that if I want to have A in front, A at the end with 2C, with the 2C between got 3 letters. So these are the possible cases that I have. So that means later, after I calculate all the arrangement, I have to multiply with 4 because we are having 4 different cases here. Okay, right, so now what we want to do now is we actually want to arrange the remaining letter. So for this one, right, I need to arrange this one 1, 2, 3, 4, 5, 6. I need to arrange the 6 letters here. So for the 6 letters here, I'm having 2A, then I have 1S, 1B, 1L, 1N. So to arrange the 6 letters here, the step that I have should be 6 factorial. Then from the 6 letters here, because I'm having 2 identical letter A, right? When I arrange them, therefore I have to divide by 2 factorial. Okay, so you arrange all the letters already, then now you need to consider all the different cases for the C, where you're having 3 letters between the C, and we already list out everything here. So that means on every single case you have to multiply. You are having the same one, 6 factorial divided by 2 factorial for every single cases. Therefore, you have to multiply it with 4. So by right, you should have 1440 for this part. Okay, and now let's proceed to 7C. Okay, so 5 letters are selected. Please highlight the keyword selected. So we are talking about combination for this question. From the 10 letters in the word of Casablanca, then find the number of different selection in which the 5 letters include at least 2A. So these are the restrictions. I want to have at least 2A and also at most 1C. Okay, so for the selection, right, for combination, when you're having the identical letter, there's no other option. You usually have to list out all the possible cases one by one. Okay, so we'll start from the first restriction, at least 2A. So that means maybe I'm having 2A. Okay, maybe I write out like this first. I'm having 2A with 0C. If 2A with 0C, right? So that means I'm having AA in my selection and then 3 empty space here to be selected. So that's the first case. And then I can have 2A and 1C, where I have 2A here and then 1C, another 2 letter from the other letter. Okay, then for third case, at most 1C, so there's no more cases with 2A and then C anymore. So now you increase the letter 3A to 3A. So I can have 3A, 0C. So 3A, 0C means I'm having A, something, something. Okay, then the next case is 3A, 1C. Okay, so 3A with 1C. I cannot have 3A, 2C, right? So now I increase the value of A again, the number of A, so become 4A. So I can have 4A, 0C. And then another case is 4A, 1C. Alright? And then after that, if you want to increase the value of A again, cannot anymore because at maximum you're having only 4A. Right. Okay, so I think these are all the possible cases that we have here. So let us come back to the first question. The first case, besides the A and C, right, the remaining letter that we have is S, B, L, and also N. So now I only consider these 4 letters to be selected and put inside the empty space because we already list out all the possible cases for A and C, right? So we are not going to consider them anymore. Alright, so you only focus on the 4 different letters here. So for the 4 letters here, I want to select 3 of them and put it inside the empty space. So for the first case here, the solution should be 4C3. Second case, same thing happened. I'm still having 2 empty space here. So from the 4 letters, I want to select 2 of them and put it inside. So I'm having 4C2. Okay, and we apply the same thing for the remaining cases. So this one, 2 empty space, also 4C2. 1 empty space become 4C1. This one also 4C1. And the last one, there's no empty space. So this is only one combination here. Only one result. Alright, so if I try to simplify everything here, 4C3 is a 4, 4C2 is a 6. Okay, then to calculate the final answer, we need to total all the combination for the different cases here. So if you try to total them, you should have 25 different combination that fulfill the restriction given in the question. Alright. Okay, so this is how we answer question number C, and this is the last question for the whole paper here. Alright, so thank you very much for watching this video. And if you have any question, kindly comment and I will try my best to answer.